little smaller is to think, wait, what if this is all of the other?
Exactly.
What if we're actually
That's what I think every single day of my life.
All right, today we're going to talk about the exterior angle theorem. That's good. Exterior angle theorem. An exterior angle is formed by one side of the triangle in the extension of an adjacent side. So here's what an exterior angle looks like. Here's one example. This. That is called an exterior angle. You see how it is formed by the red side of this triangle, formed by one side of the triangle, and the extension of an adjacent side. So the extension of an adjacent side would be this blue side, and it's extended. So when you extend the adjacent side, it forms this angle. That's an exterior angle of a triangle. If you draw another picture here of a exterior angle, and I'm going to number these angles. We'll go 1, 2, angle 3, and angle 4. In that picture, which angle is the exterior angle? 4, very good. All right. Now there's a theorem there, exterior angle theorem. It says that the measure of an exterior angle is equal to the sum of its remote interior angles. Remote interior angles. Remote, I think of far away, because you need a remote control to adjust the TV from far away, so you don't have to get up, right? Angle 4 is an exterior angle. Angle 4 has two remote interior angles, and those are angles 1 and 2. They're far away from it, and they're on the inside of the triangle. Remote interior. Make sense? The sum of its remote interior angles. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. Agreed?
So it wouldn't be 2 and 3?
Think about it for a minute. No. No. Far away, remote, and interior. Isn't angle 3 just a linear pair with angle 4?
Oh.
Okay, so this can't relate to, these are related. 3 and 4 are related. You know, the measure of angle 3 plus the measure of angle 4 equals 180. Okay. And the way you're going to use this theorem, if you look at the bottom of page 233, the example 3, and the picture diagram looks like this. This angle is 126. Up here is 6x minus 1. This angle is 5x plus 17. And you're asked to find the measure of angle J. This is angle J right here. The measure of angle J is equal to. So do you see what they've given you in this picture? They've given you an exterior angle, and they've given you its two remote interior angles. So the remote interiors added together equal the exterior. So 5x plus 17 plus 6x minus 1 equals 126. So you combine your 5x and your 6x and you get an 11x. And then your 17 minus 1 is 16, positive 16. And that's equal to 126. You can subtract 16 from each side. $11x equals, what's that, 110?
110.
And then divide by 11. These cancel, and x equals 10. So if x is equal to 10, you go back to angle J in the expression for angle J, and you replace the x with a 10. So you got 5 times 10 plus 17, and that's 67 degrees. So the measure of angle J is 67 degrees. Yes?
So I thought that it had to be 6x minus 1 plus 126, because earlier you said the measure of the other two angles were equal to the other.
This angle, the exterior angle,
Oh, okay, because the exterior angle is on the other side, that's all.
is it? Yeah. Yeah, that's the exterior angle now. It's on the outside of the triangle. Here's another, you don't need to write this down, I just want you to see it. This is also an example. You know, if this was 48 degrees, and this was 3y plus 1, and this was 2y plus 2. Okay, this is the exterior angle, isn't it? See it?
Yeah.
Okay, it's outside of the triangle. It's formed by one side and an extension of another side. So 48 would be equal to 3y plus 1 plus 2y plus 2. Okay? In this application, oh, shoot. Now here. What's the measure of that exterior angle?
90.
Yeah, that's the exterior angle right now. And it's a 90-degree angle. And if this was 7x and this was 6x minus 1, okay, this plus this equals 90 degrees, and you can solve for x. Okay? All right, turn the page. And we're going to get the third angles theorem in your notes. And it says that if two angles in one triangle are congruent to two angles of another triangle, then the third angles are congruent. If two angles in one triangle are congruent to two angles of another triangle, then the third angles are congruent. And hopefully that just makes sense. Right? If you got it, this, by the way, that's not a triangle. That's a circle. Very good. If you got one triangle here and another triangle here, and we'll call the triangle on the left ABC, triangle on the right, we'll call it DEF, and let's make angle A congruent to angle E, or angle F. They both get one arc mark. Let's make angle C congruent to angle D. Two arc marks. What do you know about angles B and E? They're congruent. Both triangles, the angles in both triangles have to sum 180 degrees, right? So if A is the same as F and C is the same as D, there's only one angle left in each triangle, right? So they have to be equal to each other, agree? Okay, so in this case, B, angle B is congruent to angle E. So if you look at the example 4 in the book on page 234, you've got triangle ABC on the left, and it looks something like this. It's a right triangle. One of its acute angles, this one, is equal to y squared. And this angle A up here has one arc mark. Got triangle DEF next to it. And it's a right triangle also. And angle D here has one arc mark. And the other acute angle is 3y squared minus 72. So angle C is going to be congruent to angle F, isn't it? You've got two angles in one triangle congruent to two angles in another triangle, so the third angles are also congruent. So your setup, if you were asked to, find the measure of, they want the measure of angle C and the measure of angle F. You got to solve for y to find those angles, don't you? So if you take y squared, you can make it equal to 3y squared minus 72. Subtract 3y squared from each side. Y squared minus 3y squared.
Negative 2y squared.
Very good. Negative 2y squared equals. Now, when these cancel out, don't forget about this negative symbol that's in front of the 72. That's negative 72. Divide both sides by negative 2. The negative 2's cancel out. So y squared equals 36. Now, if y squared equals 36, and you need to solve for y, you find the square root of both sides. That is the technique to remove an exponent of 2, is to find the square root of it. All right, because the square root of y squared is equal to y. And the square root of 36 is equal to 6. So y equals 6. So if angle C was equal to y squared, you already knew that y squared was equal to 36. So angle C is equal to 36 degrees. So what's the measure of angle F? 36 degrees. Very good. Does anybody have any questions? Okay, page 235, please. Problemos 9 through 14.